My name is Alexander Pfeiffer. I'm proud to speak at CGC Live today, and my topic is blockchain technologies and their impact on game-based education and learning assessment. My project is funded by the Austrian Academy of Sciences and the Max Kade Foundation, New York. Why is this topic important? It is possible to manipulate credentials and learning certificates. And it is hard, for example, for universities to detect such fraudulent activities. So we need to find ways how to prevent those frauds and make life easier for everyone. Why is this even important in times of COVID-19? For example, when we enroll international students for a study abroad program, we might even see copied certificates, and we have no possibilities to see the original printed certificates. So it's maybe even easier nowadays to get through with such fraudulent certificates, and it's even harder for universities and schools to find them. We also have to give grades via oral exams on Zoom, etc. So time changed a lot, and this topic changed a lot in these actual times. About me, my name, as I said before, is Alex Pfeiffer. I'm based in the US, in Malta, and in Austria. So currently, I'm a postdoc fellow at the MIT Education Accord, and most of what I'm going to present you today is the work I'm doing there. In Malta, I'm at the moment trying to achieve my second PhD at the University of Malta in the field of AI, and I will also pick up on this topic that I present today. And I run a company in Malta. It's called the PNP Emerging Technology Lab. In Austria, I'm a senior researcher at Donau-Universität Krems, and I'm co-founder of Picabyte GmbH, recently won the Austrian Blockchain Awards. I studied at Danube University, Donau-Universität, at the Wirtschaftsuniversität Vienna, the University of Economics and Business, in English, and I have an MBA from the Alaska Pacific University. So let's take an eagle-eye perspective on the topic. My project consists of three parts. One is game-based learning and assessment. So we created a serious game where you get at the end a result, a grade, and this grade is stored on blockchain. The second part is e-learning and assessment. So we created a quiz tool for an e-learning system, and again you get a grade at the end. And the grade is stored on a token, but for both of these apps, we have a different approach regarding the blockchain technology, which I'm going to explain later. And the third part is the possibility of in-person and online conducted oral exams and grading. So regarding the game has been developed by the folks from the Live Lab at Texas A&M University, and I'm very thankful for working together with this awesome team at Texas A&M. When you start the game prototype, you basically can use a default blockchain address. We used the blockchain system Ardor, to be more precise, the Childchain Ignis to create the token and the accounts. So basically you can click on using the default address, or if you have your own account, you can enter your own account address and click on verify account, and then your account is registered with the game engine to take the exam. The game itself is based on the game-based learning and assessment philosophy, meaning that on the one hand, we have the part where you can just try and practice the game and do the learning. You can simulate the assessment, and you can click on assessment. And when you start the assessment, there is a warning that your scores are being recorded, and you have to be aware of this. So for example, in future approaches, when you have 3 or 4 times the chance to pass such an exam, it's quite important that you are aware of this. In the test version of the game, we also created this test screen where you can play around with the blockchain technology, like send a text message, send a teacher token, send the student token, etc., etc. So about the game, you play the owner of a gallery, and you have to defend your artwork against a thief. to achieve a victory point, which leads to a positive grade, you have to answer 2 questions, right? So that's that you really know that the learner knows about what he's talking about. That's why we decided that 2 answers in a row actually decide if you get a positive point. So basically, you have here an icon above the head of the thief. So you have to first match the picture with the icon. This is that you pay a little bit more attention to what you're doing. And then you see the painting. You can, of course, zoom in. And in this case, it would be Impressionism. You learned about that before in the learning game or from your books. And then you move the icon to Impressionism. And the second move is always the card to the left, which if you know the right answer, you get the positive point. It's 15 turns, or it is over after 5 positive points, which would be in best case after 10 rounds. So after you finished the game, after you finished the assessment, you get the screen with the correct answers, the wrong answers, the time that has passed, your percentage, and your grade. And now we see the transaction on blockchain. We see the asset ID so we created several millions of the tokens with one particular asset ID. On that asset ID, the information as a message, as an encrypted message, is stored and being sent to the learner. So here we see already the screen from the student, and the student enters his or her passphrase, which encrypts the message and generates a shared key. Here you have the comparison of the grade that you got directly after you played the game and the encrypted message attached to the token on blockchain and the shared key created. So with the shared key, this gives you the possibility to share this particular credential with, for example, your future boss, and your future boss gets access to that particular information. Of course, for future approaches, we need to implement sub-shared keys, and we need to implement things like that you can bundle certain transactions with a shared key, like giving access to 5, 6, 7, 8 different certificates, and only for a particular time frame. So that one shared key is not giving the future boss the possibility to access your grades forever. So about the tokens, we have 3 different tokens. 1 token for the learner, 1 token for the teacher, and a gamification part. And then we have the verification token. It's a singleton token, which we need for the approval models. So the token for the learner, after an exam is passed, the encrypted message with the result is sticked to the token and sent to the learner. And then we have the approval model, which prevents that the token can be resent from the learner to another account. So basically the token with the encrypt message with the grades is forever and always attached to the account of the learner. However, if the learner, or in particular reasons, in very rare reasons, and with permission of the main account, the token could be resent to another account. But again, it needs the permission of the main account. The token for the teacher, it's the same, but with additional information from the game. And here we used pruning from the Ardor blockchain, a possibility that only the proof of the transaction is on blockchain forever, but the private content, the message, can be deleted after a particular time frame, which you set in form of the block height, of the expected block height when it should be deleted. The gamification token is an additional token that is sent to the learner in case that he passes with an A result. And then in our concept, it is possible for the learner to redeem a particular digital prize. Here we just wanted to add for this gamification part to prove that it's possible to also build gamification frameworks on blockchain, and why this is helpful. The second part is Gallery Defender, the quiz. It's an e-learning tool which can be implemented in learning management systems. Again, you can learn and practice, test yourself, take the exam. When you take the exam, you have to enter your Ardor address. So here you enter your Ardor address, you click on Start Now. And then after the quiz is finished, you have your points. And here it's a little bit different. So we did not generate millions of one particular token beforehand on which we attach the message. Basically, every single grade is a token on its own. So every single grade is a so-called singleton token, which has its own asset ID on the blockchain. Then in the asset properties of the blockchain, the message is being stored, and then the token with the grading on the asset property is being sent to the learner who just took the exam. In this case, the message of the grade is public available because it's on the asset properties, but the token IDs are not public, so only if you tell your token ID to another person, he would get access. So this was basically the idea for us to test two different approaches. Again, of course, you can here also implement phasing, etc., so that the token cannot be resent to another account. But storing the results on the asset properties is sticking the grading even a little bit more to the particular token because it's in the asset properties and not just an attached message. So here you see again the 3 steps. And here the asset which is sent to the account of the learner. So each grade has the same name, e-learning certificate, but here you see the account properties with the points, the ID, and for which account it is being issued. So again, each token has the same name but unique asset ID. After the exam is passed, the token is created on the network. The message is attached to the token and on the account properties, the token is transferred to the learner, and you can run different approval models. The third part is grading after a verbal exam in Zoom. So you have a master thesis defensio, and you like to speed up the process that the student who just passed the exam gets their certificate. So what you could do is basically that you issue the micrograding on blockchain through the whole years of the master. And then at the end, at the defensio, with the learner agreeing to it, and you as the all examiners agreeing to it with their digital IDs, you can create your certificate that stores the proof that the learner passed the final exam and is actually holding the master degree at that particular time. So we would reduce the time until a person can call himself, herself master from like 1 month to 2 minutes. The main idea is that on the account of the institute, of the center, there is a public message sent to the own account, which has a list of the enrolled students, addresses. It's still kind of private information because they would only show the Ardor addresses and not the names, etc., related to it. Then there's the approval model, which says that, so the approval model says that the token with the certificate stored on it needs to be approved by the respective student and by the accounts of the examiners, of the professors. So this token certifies the successful completion of the master thesis and has a particular asset ID. And then as an encrypted message, you store the actual information on it and send it to the teacher. Or similar to the e-learning approach, you could also, of course, create 1 single token per particular exam. So again, you have these 2 different possibilities to opt in. So again here, the message to yourself if the enrolled students is either a singleton token or a predefined set of tokens is being created with the message of the grading attached to the token. The token is transferred to the learner, and approval models can be set up again to secure the process. Let's have again an eagle-eye perspective. Which other approaches would be useful for blockchain technologies in the context of learning? This is from a paper I published some month ago, asking educators and IT professionals on the topic. And the answers show different approaches for that. For example, voting within the school, for example, for the school boy, for the scholarship management, to create digital class books, for the whole enrollment process, in the US to secure the SAT results, and for example, to create competence profiles of the learners. What's always important is the management of IDs, so that we know who has the right to issue these certificates. So basically, like, let's say the country of Austria allows the county of Lower Austria to give schools the permission that they can add teachers on the list of persons that are allowed to issue certificates. So each teacher has a registered blockchain address. Each student gets a particular blockchain address when he or she enrolls to a program. And so we actually are aware of the blockchain addresses, and we know the identity of the owners. And then you can store all kinds of relevant information on different kind of token sets that you create for these purposes. Part of exams, the annual certificates, the diploma. You can create, as we did in the prototype with shared keys, a data sharing platform where authorized persons get partial access to the grades. So what's really important in all the approaches is that blockchain technology is fine, but alone it doesn't really make sense. So you always need to combine it with digital identities. Digital identity could be self-sovereign identity. Like here is an approach that recently won the Ardor hackathon for self-sovereign identity using the Ardor blockchain in a decentralized way. And another approach would be to use decentralized authorities, for example here, the Austrian Trust Center. However, if you are a pure blockchain enthusiast, then you opt in for a decentralized way, because of course, if you opt in for a centralized way, it always depends on who is the CEO of that company, who are the political parties that are powerful in your country at the moment. So maybe for the start, we still need the official trust centers, but at the end, and that such approaches are not just for one particular country or just for the European Union, you need to go for a self-sovereign identity, in my opinion. So at the very end, it could look like that: digital identity plus blockchain plus smart contracts or some other sort of artificial intelligence and digital agents that support the whole approach. For example, digital agents signing certificates on the behalf of the dean, and only so to go back one step, after the person passes such an oral exam and the three professors taking the exam sign that it's a legit process, and then by law it also needs the signature of the dean, then a digital agent could sign on the behalf of the dean the certificate, and by random every 1 out of 20 times, it's not being signed automatically, but going on the desk to the dean to prevent fraud here, for example. So again, the eagle and the questions or the statements and the findings of the projects at the end. For us, a public blockchain should be used, or a combination of a private consortium and the public blockchain, especially the GDPR compliant part could be on a consortium-based blockchain, while the actual grading are encrypted messages on a public blockchain. Transaction fees need to be paid by the respective issuers or by the government, by the school system. At the end of the day, the operators, the learners, in the best case, do not even know much about blockchain. They just know that their credentials are secured on blockchain. So it needs to be possible that the private information is an encrypted message, and that only those parties who should have access to it, and maybe even for a particular short period, like the future boss, get access to the information, but it's not public and there forever. To achieve that, we use shared keys, as discussed before. Then, to prevent the blockchain bloat, we should only store those messages or those information forever on blockchain that should be there forever, like your degrees, so for example, we could store your master degree forever. We could store every single exam you passed to achieve the master degree for 10 years. And like other information that is only relevant for one particular year should vanish after this year. And this would truly help to prevent the blockchain bloat. But of course, the proof of a transaction remains on blockchain. Users should be possible to run a full node and store all the information in their own hands, on your mobile phone, on a Raspberry Pi. So it should be really easy to start such a process and be the owner of your data. And a digital qualified signatures, self-sovereign identity are absolutely important in the process, that you can always see who is behind a transaction and that this particular part is not frauded. So if Danube University issues a certificate, you can easily look up that it was the real account from Danube University and not a fake account setting up for this particular purpose. And then we have created this concept of the electronic ID wallet, which would look like that. It's basically a wallet that holds digital tokens like cryptocurrencies, but in this case, utility tokens. So you would have, as a person, your electronic ID wallet, which can be assigned different sets of identity verification systems, from your verified Twitter account to your government mobile phone signature, self-sovereign identity. You have all these different kind of utility tokens stored in your account. In our case, it would be the learning credentials. This eID wallet is capable of displaying tokens stored on multiple blockchains, and then you can give people access to the data who you want to give access to for a particular time frame. Of course, there are issues with like creating an account or holding a private key. We still need to educate the users that if they lose their private key, they lose access to the information stored on the wallets. So maybe for the first approach, it's a hybrid approach, that there is still kind of classic user login system with password, but in the back, like the university software is handling the private key on behalf of the student. I know that this is not pure blockchain and what blockchain should be, but we always need to think that on the one hand, we like to secure the data. On the other hand, we need to create systems where the users are not in the position that if they lose their private key, they lose all their certificates forever. So there is a lot of thinking to do on this part. Yes, that's it basically. alexpfeiffer.mit.edu. There you can take a look into the project, or on ResearchGate. Thank you very much for attending my talk. and I hope you enjoyed the conference.